Architecture diagrams are great because they help you to understand large and complex infrastructure in a single glance. There are two problems with architecture diagrams. One, they are very hard to create and it takes a lot of work. Two, they are always outdated, basically right after you created them. And this is totally normal because software evolves faster than ever. My name is Tobi, and in this video I will show you how you can fix your documentation debt for your diagrams with AI. This is an Excalidraw diagram that I've created for our AWS fundamentals infrastructure. It is already more than 12 months old, so it doesn't reflect the current state anymore. Also, because I was lazy, I've not even created the initial one based on all the components that we have. For example, we can see that there's just one CloudFront distribution, even though there are multiple. It's the same thing for the origin. The diagram says there's just one S3 bucket, even though there are multiple S3 buckets. And there are also multiple origins that are not just pointing to AWS. The process flow is also not correct anymore, because we've decided instead of going with multiple lambda function, we are creating one big monolith lambda function. This perfectly shows what I wanted to say in the beginning. Diagrams tend to be outdated all the time because your infrastructure evolves and you don't always have the time to update all your diagrams. Our infrastructure is very simple, so a simple diagram will do most of the job. But in normal projects, you have huge infrastructure, which also causes the fact that you will have a lot of diagrams. This means a lot of diagrams will always be outdated and you need to update them. In the end, this will mean you either accept that a lot of your diagrams are outdated, or you have one full-time job of always updating your diagrams based on the current state of your software. This means your diagram documentation is a mix of useful information and a lot of lies, because they don't reflect the actual production infrastructure anymore. So what is the solution to our problem? Obviously, it could be AI. With tools like Kiro from AWS or also Cursor or Claude, it doesn't really matter, we can automate the process of creating our diagrams. The cool thing about this approach is that we can not only draw diagrams for infrastructure that lives in our code via infrastructure as code, but also for infrastructure that was manually created, for example via ClickOps in the AWS console, because AI agents are able to discover our infrastructure via official MCP servers from AWS. As mentioned, you don't need to use Kiro, you can also use Cursor and Claude, but in this video we will just rely on Kiro and the free credits that we get right after the registration. Getting started with Kiro is simple. You just have to download the CLI to your local machine and then set up an account. You can either use an AWS account or you just register for a free builder ID. I've already done that before, so let's jump into the CLI. So let's start a new session with our Kiro CLI by typing Kiro-CLI. As we can see, I've already set up a few MCP servers that will be loaded in the beginning. MCP stands for Model Context Provider, and it's a global standard that acts like a universal translator or like a plug-and-play system for AI. Generally, an AI model is trapped into a jet, so it doesn't know what files are on my computer or which infrastructure resides in my AWS account. The only standard way is copying this information into your jet. But this is very tedious. Also, the agent is not able to actually do any work on our computer. And that's exactly where MCP servers come to the rescue. Basically, we have three components. The first one is the AI itself. It's like the brain of our system. The second component is the MCP server. It acts like a connector because it knows how to talk to a specific tool. So for example, to our AWS API or to the AWS documentation. The third part is the connection between the AI and the MCP server. The AI can send a request to the MCP server. So for example, please list all the CloudFront distributions in my AWS account. And the MCP server will return the data in a way the AI can understand. The cool thing about this is we can not only use remote MCP servers, but also MCP servers that run right on our local machine. This means our AI can talk to our local machine, so for example to our file system and our code, but also to remote services like I've mentioned, the AWS API. If you build your own niche tool, you can also set up an MCP server, and right out of the box, all the AI tools that support MCP, so basically all of them, can be used with your tool. Basically, MCP servers give your AI hands and eyes to talk to the real world. As mentioned in the beginning, I've already set up 3 MCP servers that we will need for our demo. The first one is the AWS diagram MCP server, which helps our AI to create diagrams via a Python library. The second one is the AWS documentation MCP server. This one is also really important because, as you remember, AI models are always trained on past data. This means the AI needs a way to retrieve the newest information from AWS. So if a service has changed dramatically, it needs to find out about this change. The third one is the AWS API MCP server, which allows our agent to directly talk to the AWS API. This can help us to get information from our accounts, but also to create actual infrastructure in our account. We can always type /MCP to see our currently configured MCP server. You can always add new MCP servers in the CLI directly by just typing /MCP add. But you can also directly open the mcp.json for Kiro by jumping into your local directory in the folder .kiro settings and then opening the mcp.json. As we can see, we can find the 3 MCP servers we just talked about in my local mcp.json file. Let's jump into the fun part and create our first infrastructure diagram. In this example, we will draw an updated diagram for our AWS fundamentals infrastructure. We've seen the old one, which I drew manually with Excalidraw in the beginning, so this one should be a lot more detailed. Let's start the process by simply typing in, please create an infrastructure diagram for our AWS fundamentals infra, and kick the process off with enter. It will take a while and Kiro will just look at our repository and probably find the right infrastructure file. As we can see, it already discovered sst.config.ts. As we are using SST, this is perfectly correct. It will now go through all the other infrastructure files because we've created a nested infrastructure folder which contains all of our more complex components. As we can see, the process stopped because Kiro wants to invoke the first MCP server. We can see it's the AWS diagram MCP server and it wants to run the command list icon, because it needs to retrieve a lot of icons to actually create the diagram via the diagram MCP server. We now have 3 options. We can allow the tool call with yes, we can reject the tool call with no, or we can use T for trust. This means that Kiro is able to use this command of this MCP server for the whole session without using another approval from us. Let's type in T so Kiro can actually continue with the process. After a few seconds, Kiro created the code that is necessary to create a diagram via the Python library that's embedded in the MCP server for the AWS diagrams. We also need to approve this tool call, so let's type in T again and press enter. As we can see in the output, Kiro successfully created our diagram in the end. It also showed us our key components and the architecture flow. Kiro will also tell us where it saved the diagram. In this case, it will be in a subfolder generated diagrams in our repository. So this is Kiro's output and I think it looks quite nice, even though we are just using the Haiku model, so not the latest generation of models. We can see that it correctly detected our CloudFront distribution as the single entrance points to our 2 Next.js applications. The Next.js applications are shown with a lambda symbol because they are actually server-side rendering applications that are deployed with SST, so this is perfectly correct. We can also see that all of our REST API services are bundled into a single API function. Another thing we can see now is that it correctly detected our GitHub Actions role because we're using GitHub Actions for our CI/CD processes. Additionally, we can also see the Cognito user pool because we've integrated a social login functionality for our newsletter. We can also see that our monolithic API function is integrated into X-Ray to support distributed tracing, and it also submitting logs and metrics to CloudWatch. The diagram is definitely not perfect, but it's definitely related to the fact that we're not using a flagship model like Opus. It still misses a lot of components. For example, our third-party APIs. We don't even see the integration into 𝗨𝗀𝗀𝗁𝗂𝘁. But nevertheless, I think it's a good start, and we didn't have to draw anything manually. We don't have to move around any arrows if we update anything in our infrastructure, because the AI model can just recreate the diagram within a few seconds. We didn't pay anything for this because we are staying in the free credits for Kiro. Let's recreate our diagram once more, but this time with a flagship model like Opus. We can switch our model easily by typing /model and then selecting Opus. Now we want to make sure that also the third-party APIs are integrated into our diagram. So let's explicitly tell Kiro to reflect this in our diagram and to create the diagram again from scratch and not reusing the previous one. Now the process is starting again, so we are going through all the steps that we've seen previously. The model correctly detects that our Hono API function is calling third-party providers. So let's have a look at the updated output. This is our updated diagram, and we can definitely see the drawbacks of the generation approach because it completely restructured how the diagram looks like. We can see that it now includes more details. So for example, Cognito is now also attached to the Lambda functions for the lifecycle hooks. So for example, the pre-token generation or the post sign-up. We can also see that all of our third-party APIs are now correctly reflected in the diagram. So we can see that we are, for example, calling plausible or post hoc. We can also see that we are integrated with Kit, our email platform, and with 𝗨𝗀𝗀𝗁𝗂𝘁, our payment provider. So what is the summary for creating architecture diagrams in the future? I think there's still a place for tools like Excalidraw. So for example, we can use it for quickly drawing sketches of new infrastructure or brainstorming new ideas. For creating and maintaining diagrams for existing infrastructure and for real products, I think we should slowly transition to using tools like Kiro in combination with MCP servers, because we can more easily create diagrams that reflect the current state of the art of our infrastructure. The diagrams are definitely not perfect, but they reduce a lot of manual work. I think in the future we should switch to using AI in combination with MCP servers, and we are switching our roles from being the craftsman to being a reviewer of the output of the AI. Basically, it should go in the same direction as crafting software in general. We will create things with the help of AI, but AI can do the heavy lifting and the manual parts we don't want to do anymore. My recommendation is to experiment with the free AWS MCP servers we learned about in this video and just to explore what they are capable of. Maybe you can create your first architecture diagrams for infrastructure that doesn't even have infrastructure as code and show this to others. And if you're new to AWS, make sure to visit our infographics section where you can learn the most important things about all the AWS core services. Thank you for watching and see you next week.